Hi everyone and welcome to the internet. So what we're going to be doing in today's lesson is having a look at gravitational field and potential energy. So hopefully by the end of this lesson you'll be able to describe and explain weight and how we can calculate it. So to start us off, as always, we've got a couple of questions on the screen there for you to have a go at in your books. So you can use a calculator as always, and I've given you the formula at the bottom you may need. So everyone have a go at answering those questions in your book for me. I'll give you a couple of minutes to get that done. Okay then, let's see what we got. Obviously tick them if you get them right, if not then cross and correct. So the graph of force against extension for the elastic band is on the left hand side there, so kind of an S shape. And then on the right, the one for our spring starts off with that straight line and then it curves. And then for number 2, our calculation, hopefully we got the answer of 0.625 with the units joules. So give me an idea who got 3 out of 3, who got 2 out of 3, who got 1 out of 3. Post your number in the chat window for me. The first thing we're going to have a look at today then is what we actually mean by a few of these terms we're going to be using in today's lesson. So the first one, gravitational field, quite simply is a region where a mass will experience an attractive force. So anywhere that this mass is going to experience an attractive force, that is a gravitational field. The second one, gravitational field strength, which we might also refer to as gravity constant or just G, then this is a measure of the force on a 1 kilogram mass when it's in a gravitational field due to another mass. So make sure you've got those two definitions written down. The last point I've got on your screen there, just stating that mass does not change, is something that's going to be very important to us as we go through this topic. So remember, mass is the amount of stuff, if you like, that something is made from, and that won't change. However, things that then affect the mass could. So mass itself will not change, but when we come on to look at some other factors, then they can. So make sure you've got those points written down. I'll just give you an extra 30 seconds to get those if you haven't already. Now, if we consider what is actually going to affect this force that acts on an object within a gravitational field, we've actually got two key factors here. So the first one is the mass of the object, and the second is the distance between them. So our first little pattern that we need to remember then is about mass. So what we find is that the gravitational field will be larger if the mass is larger. So bigger masses mean bigger gravitational fields. And the second one, in terms of our distance, if we've got those two objects closer together, so the distance is smaller, then we have a larger gravitational field. So two ways that we'll have a larger gravitational field is if the mass is larger and if the distance between them is smaller. Make sure you do have those points written down because patterns are always important in science. So again, I'll give you about 30 more seconds to get that if you haven't already. It just doesn't feel like a lesson in P2 if we don't have a formula. So here's another formula for us to learn. And again, this is going to be one that they're not necessarily going to give you in the exam, so it's on the list of equations you've got to memorize. So the gravity force in newtons is the mass in kilograms times the gravitational field strength, and that's measured in newtons per kilogram. So make sure you write that down, stick it in a box, highlight it, do something to make it stand out, and add it to what I hope you've already got as a bank of flashcards for these different formulas you've got to memorize. Now, the next thing we're going to have a look at is just an example of how we can use this. So a spacecraft has a mass of 60 kilograms and is in the gravitational field of a planet where G is 27 newtons per kilogram. Calculate the gravity force on the spacecraft. So what we do, as always, when you read the question is underline, highlight or circle the key information, and then the next step is we write down the formula we are going to use. So in this case, it's gravity force is mass times the gravitational field strength, which we can shorten down just to GFS for ease. Then what we do is we substitute in those values from the question. So mass is 60 kilograms and our gravitational field strength is 27. So 60 times 27 is what we need to do. Get your calculator out, put those numbers in, and hopefully we would get an answer of 1,620 newtons. In the orange box towards the bottom left, you can see I've given you another exam tip, which is the gravitational field strength here on Earth. Now, I'd suggest you remember this one. It's a nice easy one to remember. It's 10. So gravitational field strength on Earth is 10 newtons per kilogram. So make sure you've got that jotted down in your books. If you haven't already, I'll give you another 30 seconds to do so. Okay, now it's your turn to have a go at some questions. So I've just given you a couple of questions on the screen there. So show your working in your books and then use a calculator if you need to find the answers. So 2 calculations to have a go at. I'm going to give you a couple of minutes to get those done. Okay then, let's check our answers, and as always, mark your work as we go. So our first one, then the mass was 80 kilograms, and we're on Earth, so gravitational field strength was 10. So 80 times 10 gives us 800 newtons. So tick that if you got it right. Then for our second one, what we're looking at is we were asked about what happens to the mass and what happens to the weight. Now, mass doesn't change. Remember, we said that at the start of our lesson. So the 75 kilogram mass will still be 75 kilograms. The weight, however, is affected by the gravitational field strength. So we do 75, our mass, times the gravitational field strength of 5, gives us 375 newtons as the weight. So give me an idea, who got 2 out of 2, who got 1 out of 2, who didn't get anything right. In the chat window, let me know. So we've used two very important terms that a lot of people mix up: mass and weight. Now, these are not interchangeable terms, folks. Let's see if you can write me a definition for mass and a definition for weight in your books. So I'll just give you about a minute and a half. Definition for mass, definition for weight. Off you go. So hopefully for mass, you've got something along the lines of the amount of stuff that something is made from. So it's the amount of physical material that something is made from. Whereas the weight is the force of gravity acting on an object's mass. Now, another couple of questions for you to have a go at just underneath. If you haven't got those definitions, obviously do correct them. And then I want you to have a go answering those questions in your book. So how do you calculate weight? Why does your weight change on different planets? And suggest why your weight on the moon is 1/6 your weight on Earth. So I'll just give you a couple of minutes to have a go answering those. So to calculate weight, it's mass times our gravitational field strength. Why our weight will change on different planets is all down to the fact that different planets will have different gravitational field strengths, and the reason that our weight on the moon is 1/6 the weight of that on Earth is because the moon has a force of gravity 1/6 as strong as that on Earth. So tick each one of those you got right, and obviously make sure any corrections are corrected. So we use the lowercase g to refer to our gravitational field strength, but we can also use it to stand for the acceleration due to gravity. So we've already said that gravity force is the mass times the gravitational field strength, but we could also talk about this in terms of our resultant force. So resultant force, still in newtons, is the mass in kilograms times the acceleration due to gravity. Now on Earth, acceleration due to gravity is 9.81 meters per second squared. They will accept it as rounded to 10, but obviously if you want to be super accurate, 9.81 is the correct acceleration due to gravity on Earth. Just a little tip for you, again, these are equations you must know for the exam, so add them to your list, add them to your flashcards, and one thing you can certainly be doing in this time is just memorizing these physics formulae, because we know there's a lot to learn, so the more you can do now, the better you'll be set up for the future. So let's have a go at using that formula then. Question is on the screen for you. Calculate the resultant force of a 2 kilogram stone falling on Earth. The acceleration due to gravity is 9.81 meters per second squared. So write your answers in your books. I'm only going to give you about another 40 seconds to do this. So all we need to do in this one is remember that obviously our resultant force is mass times acceleration due to gravity. So substitute those in, is 2 times 9.81, which gives us an answer of 19.62 newtons. Again, tick it if you got it right, folks. So the last part of this is really looking at this idea of gravitational potential energy. Now, why we actually consider this is because when we lift an object within a gravitational field, then we're transferring energy to a gravity store. And this energy we call gravitational potential energy, or GPE for short. Now, there are two things that are going to actually determine the GPE an object has. The first thing is the mass of the object, and the second is its height. Obviously, the other thing that will influence this is gravitational field strength, but quite often these questions are based on Earth, so it will be the height and the mass that are varying more than gravitational field strength. The bad news, there's another formula for us to learn, which is at the bottom there. So GPE, which is obviously energy, so it's measured in joules, is the mass in kilograms times the height in meters times gravitational field strength in newtons per kilogram. So make sure you learn that, add it to your flashcards, sit, practice, get it in your head sooner rather than later. So I'll just give you another 35-ish seconds to get that written down if you haven't already. Okay, so the kind of question they could ask us is here. Calculate the energy transferred to a gravity store when a man of mass 70 kilograms goes from the ground floor to the 40th floor of a skyscraper. Each floor is 3 meters high. So, see if you can answer that question for me in your books. Don't forget to show you're working. So I'll just give you about a minute just to have a go at that. So, as always when we do these, when you read your question, don't forget underline, highlight or circle the key information first of all, so you don't have to keep rereading it over and over again. Then what we're going to do is write down our formula that we're going to use. In this case, gravitational potential energy is mass times height times the gravitational field strength. Then we need to have a look and see what we substitute in. Now, mass is easy, it's just 70 kilograms, so we can just put 70 in for mass. But the height, we're not given the overall height. We've got to work that out ourselves. So we're told that each floor is 3 meters high and we're going up to the 40th floor from the ground. So we need to do 3 times 40 to get the overall height, which gives us 120, and then we can substitute that into our formula. We are on Earth, so our gravitational field strength is 10, so our final calculation we need to do is 70 times 120 times 10, which if you put that into your calculator should come out at 84,000 joules. So tick it if you got it right. If you went wrong somewhere, obviously highlight the bit you went wrong on and write the correct way in your books. I'll just give you about another 15 seconds in case you need to do corrections. Just to really practice this, then we've got a couple of questions here for you to have a go at answering. So again, show you're working as you go through and answer these in your book for me. So I'll give you a couple of minutes to get those done. Okay, let's check those final answers then. If we're calculating the energy transferred to a gravity store when a person of mass 60 kilograms goes from the ground floor to the 20th floor of a skyscraper, each floor is 3 meters high, then we need to do 60 times 20 times 3 times 10. So we should have 36,000 joules. Number 2, calculate the energy transferred to a gravity store when a 70 kilogram person carrying their 12 kilograms of toilet roll and hand sanitizer climbs to the 16 floors of their home. Each floor is 3 meters high. Then remember, we've got to do a little bit of calculating here. So, first thing is it's not just the person, it's the person with all their toilet rolls and hand sanitizers. So 70 plus 12 gives us our overall mass. Then we're going to multiply that by the overall height, so 16 times 3. And then we multiply that by gravitational field strength of 10. So that will give us 39,360 joules. Again, tick them if you got them right. So the last part of today is our plenary task. So take your pick, obviously based on your target grades. You've got either the 5 and the 6 that you can have a go at, or try the 6 and the 8 questions. There is also a challenge question at the bottom for you. So I'll leave this up here for about a minute, but if you need longer than that, obviously just pause the video so you've got a chance to answer the questions. As always, you can find the answers to the plenary, some additional work, and other bits and pieces on my website. The link is on the screen there for you. Hopefully you found today useful, and I look forward to seeing you again in our next lesson.